Hey guys, welcome back, and today we're going to be going over 7.5, which is solving trigonometric equations. And this is kind of what we've done before, except um, we're just going to add a little bit to it. And for the think/warm-up, I recall what the principal values are, which I'm just going to skip right to it. There are solutions for our trig expressions that are restricted. So normally, right, when we get the trig function of some angle, we can actually, or we get some value from some angle. Really, there's two angles that can give that same value. And our principal values, we've worked with them before, just basically say, hey, only work with this set of angles, so you only get one answer. So for sine and tangent, they're between negative 90 degrees and 90 degrees. And for cosine, it's between 0 and 180. And so before we start solving any of these, just some tips, and there's really only two. So factor and use the zero product property, and we'll talk about what that is. You've done it before with factoring. And two is use the trig identities to rewrite expressions in terms of only one trig function. So this first one solves sine of x times cosine of x minus 1/2 cosine of x equals 0 for principal values of x. So principal values express solutions in degrees. So what I'm going to do here is I see both of these terms actually have a cosine of x. So I'm going to take out or factor out a cosine of x, and what I'll be left with is sine of x minus 1/2 equals 0. And the zero product property says, hey, this is multiplication here, right? And 0 times anything is 0. So if this is 0, if cosine of x is 0, this statement is going to be true because 0 times anything is going to be 0. And then if sine of x minus 1/2 is 0, then this statement's going to be true, right? Because this will be 0 times cosine of x doesn't even matter. 0 times anything is 0. So now we just solve both of these. So remember, you can take cosine inverse here, right? Whose angle, really what we're thinking, whose angle when we take the cosine gives us 0. And to do that, I will probably think of our graph if I'm not using a calculator, right? 2 pi, pi, pi halves. And it's going to be pi halves, right? Because that's a principal value. 3 pi halves would be outside our principal values. So, and it wants it in degrees. So x is 90 degrees. Right? Pi halves is 90 degrees. Pi is 180, so pi halves is 90 degrees. Now this one we have to add 1/2 over. And now whose angle is the sine 1/2? That one is going to come from our 30, 60, 90 triangles, but you might have this one memorized at this point, 30 degrees. So if I take the sine of 30 degrees, I get 1/2. And so those are our two answers. All right, for this one, solve cosine squared x minus cosine x plus 1 equals sine squared x. Well, we're going to have trouble factoring this and setting it equal to 0, right? So maybe the first thing we can do is we know our second tip was replace something so that they're all in terms of one trig function. We know sine squared, we know that's the same as 1 minus cosine squared x, right? The Pythagorean identity, sine squared plus cosine squared equals 1. If I subtract that cosine squared over, we get sine squared equals 1 minus cosine squared x. Well, and now we can kind of do this, right? If we add cosine squared over, we're going to get 2 cosine squared x. Then if I subtract 1 over, right, then those ones end up canceling. So I'll get 2 cosine squared minus cosine of x equals 0. And again, I could take out a cosine, and I'll be left with 2 cosine of x minus 1. Now I could use that zero product property again cosine of x equals 0, and 2 cosine of x minus 1 equals 0. It's going to be our two equations. Where's the cosine 0? We already did that earlier, but now it wants our answers from 0 to 2 pi. So down here, where can the cosine be 0 if I'm thinking on our graph, right? 2 pi, pi, pi halves, 3 pi halves. So from 0 to pi, it's going to be pi halves, 3 pi halves, so x equals, and then here, if we add 1 over, we're going to get 2 cosine x equals 1, and then divide by 2, whereas cosine of x 1/2, and that's when x is 60 degrees, which is going to be pi thirds, right? And if we think about it, excuse me, if we think about it, cosine of x is also, because this doesn't say principal values, it just says all values, so ASTC, positive 1/2, so we got the pi thirds or 60 degrees here, and then cosine is also positive here, where this is 60 degrees, so really we go 90, 180, 270 plus 30, 300 degrees, right? Or we could say negative pi thirds, doesn't really matter, but those are our options. Actually, just since we left the other ones positive, we should make this one positive. 300 degrees would be 5 pi thirds. And the way I get that is I know all the way around is 2 pi, right? So I have 2 pi minus pi thirds, which would be 5 pi thirds. And so those are all of our answers put together. Pi halves, 3 pi halves, pi thirds, 5 pi thirds are all answers to this question. Solve 2 secant squared minus tangent to the fourth x equals -1. Again, we have secant and tangent. We probably want things in terms of all tangent or all secant. I see secant squared, I'm immediately thinking of a Pythagorean identity. We could replace secant squared with 1 plus tangent squared. Minus tangent fourth of x equals -1. 2 plus 2 tangent squared of x minus tangent to the fourth x equals -1. And now we can write this as, I think maybe, so let's add the 1 over, right? If we add the 1 over, then we get, and I want to write this in descending order, negative tangent fourth to the x plus 2 tangent squared x plus 3 equals 0. And then I just want to divide everything by -1. So really just switch all the signs. So that this is positive. And now we can factor this. We know tangent squared is going to go here and here to get tangent to the fourth. And then we're going to need to do -3 plus 1. -3 plus 1, because this will get us -3 tangent squared x plus 1 tangent squared x is going to leave us with -2 tangent squared x, and that'll leave us with -3. And so now we use that zero product property. We get tangent squared of x minus 3 equals 0. and tangent squared of x plus 1 equals 0. Tangent squared x equals 3. So tangent of x equals the square root of 3, right? Really the plus or minus if we take the square root of both sides. And we know the ones that do that is when at 60 degrees. And again, you could use your triangles or just take tan inverse of both sides. But here's something we need to think about. Up here, it says for all real values of x. So we have pi thirds, right? But this is also going to be true for every period of tangent, right? Because sine, cosine, and tangent are periodic, they repeat values. So since it says for all real values, we're going to have to do plus, and then we usually think about adding 360 degrees to keep something the same. But for tangent, the period is pi, so every pi it's going to repeat. And so we could just say pi k, where k is any integer. And then since we have this negative square root of 3, we also have or x equals negative pi thirds. And then again, plus pi k, because it's that period, it's going to repeat itself. This one, we're going to get tangent squared of x equals negative 1. Well, and then this isn't going to be a real solution because we'd get tangent x equals the square root of negative 1. So can't do that, right? Unless we're talking imaginary numbers, which we are not, because it says for all real values of x. So really down here is all we have to worry about. Those are all the real values. All right. When you ride a Ferris wheel that has a diameter of 40 meters and turns at a rate of 1.5 revolutions per minute, the height above the ground in meters of your seat after t minutes can be modeled by the equation blah. How long after the ride starts will your seat be 31 meters above the ground? So we have the height is 31 meters. And we're just going to set that equal to the rest of the equation. 21 minus 20 cosine 3 pi t, and we're looking for t here. If we subtract 31, then we're going to get 0 equals negative 10 minus 20 cosine of 3 pi t. And now looking at it, I actually probably want that 10 over here equals negative 20 cosine 3 pi t. If we divide both sides by negative 20, we'll get negative 1/2 equals cosine of 3 pi t. And now here we're saying whose angle, so 3 pi t is, so cosine of what gives me negative 1/2? Well, I know 60 degrees is the positive one, but again, we need to take into account a STC, right? So we know the normal one is 60 degrees, but where is it negative? And that's going to be in these two quadrants. So 180 minus 60, or 120, right? So, and since we're in pi's here, so we know that this angle, 3 pi t, we know that this angle is, that would be pi minus pi, what can I think? That would be pi minus pi thirds, which would be 2 pi thirds. Right, so 2 pi thirds, and also for every 2 pi after that, 2 pi k, where k is an integer, right? Because if we add 2 pi or subtract 2 pi, we're right back where we were. And then or because we're also here, right, so that's pi plus pi thirds, or 4 pi thirds, 4 pi thirds, and again plus 2 pi k, because if we add 2 pi or go a full revolution around, we're exactly right where we were. Okay, now we can divide everything by 3 pi. Really what's going to happen here is this is going to turn into 9 pi, and the pi's are going to cancel. So we get 2 ninths plus pi and pi cancel, 2/3 k. I'm just going to write the k out front, equals t. So that's the time we're looking for. Or, and then here if we do the same thing, divide everything by 3 pi. Again, we're going to get over 9, and then the pi's are going to cancel. 4 ninths plus 2/3 k. Remember, the k is just how many revolutions we've basically already decided to go over. And so these are technicalities, right? Adding these plus 2 pi's, but we know that if we're going around this Ferris wheel, right, the shortest time that it's going to be is when k is 0, before we've actually gone a full revolution, right? When you start at the bottom of the Ferris wheel and you start to go up, it's going to be before you've hit a full revolution. You're going to be at 31 feet, right? And then if you go all the way around, right, essentially this is what this is. Go all the way around, and this is why we have two answers, because here you're also 31 feet off the ground, right? And then that would be that plus 2 pi if you were here and then you went all the way around. Plus 2 pi, plus 2 pi, plus 2 pi, right? And so our actual answer would be when you're here and then you first move up right here to 31 feet, and that'll be when k is 0, or when we don't have, when we haven't gone a full revolution yet. So 2 ninths, right? Not the second one, which 2 ninths of a minute is about, so 2 ninths of a minute is about 13 seconds. All right, one more. And so this is an inequality, but we could still kind of use our brains and what we know for this one. I'm just going to kind of treat this like an equal sign, but remember, if we multiply or divide by a negative, we have to flip the sign. First, I'm going to subtract 1, so we get 2 sine theta is greater than -1. Then divide both sides by 2 to get sine theta is greater than -1/2. Again, I'm going to kind of treat it as if it's an equal sign. If I was at an equal sign, where is sine of theta 1/2 or -1/2, right? So I know sine of theta is 1/2 at 30 degrees, but I need to take into consideration ASTC. Actually, I made that another A. ASTC. So that'll be 30 degrees, but it'll be 30 degrees with the reference angles here and here. So in radians, because we're 0 to 2 pi, it probably wants it in radians. That's going to be at pi plus pi 6, or sorry, I can't think right now. Pi plus pi 6 would be 7 pi 6. And here we would have we'd have 2 pi minus pi 6, or 11 pi 6. And if you need to do the calculations of what radians is, that's totally fine. And now from here, we have to think, we need the angle, we need sine of theta to be greater than this. And this is where I think a unit circle would come in handy, right? So if I had a unit circle, and it's talking about these two angles here, we're at 7 pi 6 and 11 pi 6. Sine is the y values, right? on a unit circle, where are all the y values bigger, right? The y values are going to be bigger above this one and above this angle, right? So really, what we have is, if we're keeping it with this, we could say that all of the angles between 0 and 7 pi 6, not including 7 pi 6, because just a greater than symbol, and then, or, so the union, 11 pi 6 to 2 pi. 11 pi 6, not included, to 2 pi. And we don't really need to include 2 pi because it's already included here at 0, basically. And so this would be our answers. But it's basically all of these angles. And I suppose if you wanted to write it a better way, maybe you could say negative pi 6 to 7 pi 6. Maybe you could write that. Who knows? I think this way is better because 7 pi 6 is technically you're getting into those negative angles, so I think it's better you're either writing it with all negatives or all positives, and it's hard to tell which way you actually mean it, like this. So I think this is more clear, so I actually wouldn't do it that way. But that is going to wrap up 7.5.